Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and today I'm going to talk about the different pressures associated with VAV box data. Let me start by pulling up part of a catalog page for our ESV radiated sound data. The data table shows several different pressures. Over here we have minimum delta P. Across the top you see columns for 0.5, 1 inch, 1.5, and 2 inches delta P. And then not shown on the page is that the data assumes 0.25 inches of downstream static pressure as well. So let me draw a VAV box and some ductwork. So here we have the VAV box. Draw an inlet into it, some discharge ductwork, and we're going to make a really bad turn into a diffuser just so I can show this as an example. So I feel I have to say, please don't ever do your diffuser at the end of your ductwork just turning right into it with a hard 90 like this. Okay, so the air is going to leave your box and go through the ductwork and out the diffuser. The pressure loss through this path is your downstream static pressure. Okay, so let me draw a damper in here. I left that out, and we're going to have the damper be wide open. The minimum delta P is the minimum pressure loss across the box with the damper wide open. So you can see up here we have maybe 0.4 inches on a size 5 at 300 CFM. Sorry, 0.04 inches. If that's the minimum DP across this box, and we have 0.25 inches downstream, you have to have at least 0.29 inches at the inlet to get the air through the box, through the downstream ductwork in the diffuser, and out into the space. Now up here on the sound data you see shown 0.5 inch, 1 inch, 1.5, and 2 inch delta P. This has to do with the inlet pressure, but it is not equal to the inlet pressure. Let me make a little bit more room here. Sometimes in this sound data table you will see a 1/2 inch, 1 inch, 1.5, and 2 inch inlet pressures. And that is the pressure at the inlet of the box. Delta P is the inlet pressure minus the downstream static pressure. So let's say you have 1 inch inlet pressure and you have 0.25 inches downstream, so your delta P will be 0.75 inches. So like the minimum delta P, the delta P shown in the table across the top of the sound data is the pressure loss across the box from the inlet to the discharge. So if I said that the minimum delta P is 0.4 inches, why would I have, say, a 1/2 inch delta P? Basically, the damper is closed down to maintain the 300 CFM through the box. If you remember, pressure-independent VAV boxes open and close their dampers to control the airflow regardless of changes in pressure in the system. As the damper closes, the pressure drop will increase across the box, and that makes the sound go up. It's important to know the difference between your inlet pressure and your delta P, because if you're comparing data from two different manufacturers, you don't want to compare 1 inch inlet pressure to 1 inch delta P. So to summarize, the downstream static pressure is everything after the box, down here through the diffuser. The minimum pressure is the minimum pressure loss across the box with the damper wide open. The inlet pressure is how much pressure you have available right here at the inlet. And then the delta P is the actual pressure drop across the box, which will probably be higher than minimum pressure because your damper will be modulating open and close. So there you have all the different pressures associated with VAV box data. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.